Hello everyone! Today we're going to discuss motion in a straight line lab using a simulation called Moving Man. This simulation, created by the University of Colorado Boulder, will help us visualize and understand the relationships between position, velocity, and acceleration. First, to access the simulation, you will need to navigate to the website. You can do this by opening a web browser and going to this link, https://jas.fet.colorado.edu simulations Moving Man. The title of this lab is Motion in a Straight Line, describing one-dimensional motion. The primary goal of this lab is to examine position and velocity graphs of an object moving in different ways. Before we get started with the lab activities, let's review some key concepts. Speed is the distance traveled by an object in a given time interval. This can be written as v equals to dx divided by dt, where ev is the speed, dx is the distance traveled, and dt is the time interval. Acceleration, on the other hand, is the rate of change of speed with respect to time, or I equals to dv divided by delta. dv is the change in velocity in time internal dt. If an object is moving with constant speed in a straight line, its acceleration is zero. Let's open the simulation using the link provided. Once you open, it gives you two options to load. Choose Run ChirpyJ browser compatible version. It will take some time to load, and once it loaded, you will have simulation shown in the bottom picture with man in the center. The simulation has two tabs, Introduction and Charts. This lab uses the Introduction tab. The simulation includes controls that allow you to move the man, make him move automatically, record and play back his motion, and reset the simulation. The controls include position, velocity, and acceleration sliders. Once you run simulation, you can record the data using playback. Make a table of the data time versus position in an Excel sheet or any other graphing program. Make a position time graph with time in the x-axis and position in the y-axis. Also draw a trend line using the graphing software. The position time graph with constant velocity setting looks like the graph shown here. Now reset the simulation. First of all, set constant acceleration. For example, I set a equal to 0.5 meter per second square. Now run the simulation. You can record the data using playback. Make a table of the data position versus time in an Excel sheet or any other graphing program. Make a position time graph with time in the x-axis and position in the y-axis. Also draw a trend line using the graphing software. In this case, fit a second-order polynomial. Also make a data table with velocity versus time. Make a velocity time graph with time in the x-axis and velocity in the y-axis. Also draw a trend line using the graphing software. The fit line will be a straight line. The position time graph and velocity time graph with constant acceleration setting look like the graph shown here.